Welcome to the fourth lesson in session 4 on identifying the focus and directrix of a parabola. The vertex of a parabola is halfway between two important components of the parabola, one called the focus and the other called the directrix. The focus is a point that lies on the axis of symmetry, just tucked inside the curve of a parabola. Very similar to the foci of an ellipse and of a hyperbola, it's always tucked just inside the curve. The directrix is a line that's outside the curve of the parabola that's perpendicular to the axis of symmetry. So in the diagram below, you see the curves, and notice just inside the curve is a coordinate that's called the focus, and just outside the curve you see a line that's perpendicular to the axis of symmetry. That's called the directrix. Now the focus and the directrix lie c units from the vertex. So as the first line states, the vertex is halfway in between the focus and the directrix, and c represents the distance from the vertex to the focus and the distance from the vertex to the directrix. Using the vertex form of a parabola, the value of c is found using the formula a is equal to 1 over 4c. And we generally use the absolute value of a because positive or negative doesn't matter, since in one direction you find the vertex and in one direction you find the directrix. So the sign of a does not have any impact on finding the value of c. But a is equal to 1 over 4c is the equation that we use to identify the distance from the vertex to the focus and directrix. In the next examples, we're going to be asked to identify the value of c for each of the equations. In the first equation, we have y equals 3 times the quantity of x minus 1 to the second power plus 1. Now the only thing that's important in identifying the value of c is the value of a in the equation. So in this case, the value for a is equal to 3. So we use our formula, a is equal to 1 over 4c, and we plug in the value of a, and we get 3 is equal to 1 over 4c. Now we want to treat this as a proportion, and we're going to use the cross product to isolate the variable and solve it. So we end up with a value of c is equal to 1 over 12. What this tells us is that the focus and the directrix lie 1/12 of a unit away from the vertex. In the next example, the equation reads x equals negative 1/8 times the quantity of y minus 1 squared plus 1. So in this equation, the value of a is equal to negative 1/8. Now, when identifying the value of c, now the value of a being positive or negative doesn't really have any impact. So we don't worry too much about the negative sign since we're just identifying the value of c. So I set up the equation as 1/8 is equal to 1 over 4c. And again, we're going to use the cross product to get 4c equal to 8. Dividing both sides by 4 gives us a value of 2. So the value of c in this case is equal to 2. And what that tells us is that the focus and the directrix lie 2 units away from the vertex. In the next example, we're going to ask you to identify the coordinate of the focus and the equation of the directrix for the given parabola. So the equation is y equals 1/4 times the quantity of x plus 1 squared minus 2. And as you can see, the graph is provided. So here we have a vertical axis of symmetry given at the equation x equals negative 1. The vertex of this parabola is at negative 1, negative 2, and the parabola is opening up. So in order to find the focus and the directrix, I need to find the value of c. So the value of c is given by the equation a is equal to 1 over 4c, and in this equation I have a value of a that's equal to 1/4. So I set up the equation as 1/4 is equal to 1 over 4c. And we'll find the cross product and solve, and we get a value of c is equal to 1. So what that tells me is that the focus is going to lie 1 unit above the vertex, since the focus is always tucked just inside the curve. So if I go 1 unit up from the vertex, I'm at the coordinate negative 1, negative 1. Now the directrix is located 1 unit beneath the vertex in this case. So the vertex is given by a line. It's always going to be perpendicular to that of the axis of symmetry. So the directrix is going to be that of a horizontal line, And in this case, it's going to be take the value of x equals, or y equals, excuse me, y equals negative 3. So again, the value of c is equal to 1, telling us that the focus and the vertex lie 1 unit away from the vertex. And based on the orientation of this parabola opening up, I know that the focus lies 1 unit above the vertex at -1, -1, and the directrix lies 1 unit underneath the vertex, and that takes the equation of the line y equals negative 3. In our last example here, we're going to ask you to do the same thing. We're just identifying the coordinates of the focus and the equation of the directrix for the parabola x equals -1/2 times the quantity of y minus 2 squared plus 3. Now the graph of the parabola is provided. So as you can see, we have a vertex at 3, 2. The axis of symmetry is horizontal and takes the equation of y equals 2. And this parabola is going to open to the left, and that matches the value of a here since it's negative. So now we need to find the value of c so we can identify the location of the focus and the directrix. So we use the value of -1/2. The negative doesn't matter. A is equal to -1/2, but we're not going to use the negative. So we set up the equation as 1/2 is equal to 1 over 4c. And once we find the cross product, we're going to end up with a value of c that's 1/2. So in this case, what that tells us is that just inside to the left of the vertex, I have my focus. So the focus is going to take a half a unit inside, so that's going to give us the value of 2.5, 2. Now we find the directrix is located a half unit away from the vertex on the outside of the curve and perpendicular to the axis of symmetry. So there's what the equation looks like, and that's going to take the equation of x equals 3.5. So that wraps up our lesson. Please email us if you have any questions. Good luck on the quiz.